the final frontier of fear and wonder. There are places in our universe that defy imagination. They are voids in the fabric of space itself, where the laws of nature, as we know them, are pushed to their absolute limits. These places are born from the death of giants and possess a hunger so profound that nothing, not even the fleetest particle of light, can ever hope to escape their grasp. They are the ultimate mystery, wrapped in a shroud of impenetrable darkness. They evoke a primal fear within us, a terror of the unknown, of being consumed by an inescapable force. But alongside that fear, there is an undeniable, powerful sense of curiosity. We are drawn to them, compelled to ask, what would really happen if you fell into one? Imagine yourself floating in the silent emptiness of deep space. So, let us begin. What precisely is this terrifying object we call a black hole? In the simplest of terms, a black hole is a region of space-time where gravity is so overwhelmingly powerful that it creates a one-way door. Once something enters, it can never leave. Not because of a surface, but because space itself is flowing inward faster than light. Even light is not fast enough to escape its clutches. It appears as a sphere of perfect blackness against the stellar backdrop. Born from the death of giants, cores crushed by gravity beyond all other forces. If the core exceeds roughly 3 solar masses, collapse becomes inevitable. Around an infinitesimal center, space-time is forever altered, sealed from the universe. Like a deep dent in a rubber sheet, get too close and you spiral inward with no return. Every black hole is surrounded by a crucial, invisible boundary. Not a surface you can touch, just a geometric line in space-time. Scientists call it the event horizon. Like a calm river toward a colossal waterfall, far upstream you can still paddle back. Cross a certain point and no effort can fight the current. You are destined to go over the falls. Once you cross the event horizon, your fate is sealed. No signal, no light, no part of you can ever get back out. Crossing itself might feel uneventful. Only your instruments would know. Ahead, darkness. Behind, familiar stars, increasingly distorted. To a distant friend, you slow, redden, and freeze at the edge. They would never see you cross as your image fades into black. As you descend past the event horizon, you meet a bizarre effect of extreme gravity. Spaghettification, a whimsical name for a gruesome process. It is the consequence of tidal forces. Near a black hole, those forces are amplified unimaginably. The nearer part is pulled much more strongly than the farther part. You are stretched lengthwise and squeezed sideways. It continues until molecular bonds can no longer hold. You are drawn into a thin stream of atoms, like spaghetti. Bones, organs, cells, everything unravels. A river of particles, a silent testament to overwhelming gravity. Small stellar holes kill outside the horizon. Supermassive ones delay the stretch. You could cross intact, only to face spaghettification deeper within. One of Einstein's profound lessons. Time is not a constant. Time is relative. It can be stretched and compressed. The stronger the gravitational field, the slower time passes. We measure this every day with GPS satellites. As you fall, your own watch ticks normally. Your heart beats as usual. But for a distant observer, your time runs much more slowly. You would watch stars being born and dying in the blink of an eye. Galaxies rotate and collide in a sped-up cosmic ballet. Signals from you take longer to climb out. Your image reddens and dims. From afar, you freeze at the edge, fading away. You have entered a region where time flows at a radically different rate. Your present has become their unreachable past. The journey would be a spectacle of unparalleled visual distortion. Gravity bends space-time and the paths of light. Gravitational lensing is observable even from Earth. Near a black hole, lensing becomes psychedelic. Familiar constellations twist into unrecognizable patterns. You may see multiple images of the same star at once. Sometimes light smears into a perfect Einstein ring. Inside, the singularity's blackness fills most of your forward view. Behind you, the universe compresses into a shrinking, brilliant window. Colors shift bluer. Radiation intensifies, beautiful and terrifying. You might even see the back of your own head as light loops around, a final, disorienting vision before the end. At the center lies the black hole's ultimate secret, the singularity. A place so extreme it breaks our laws of physics. According to general relativity, zero volume, infinite density. All mass of the star, and all that fell in, compressed beyond atomic scale. Space-time curvature becomes infinite. Sense collapses. Relativity predicts starlight bending in gravitational waves, yet has limits. Infinite values make the math fail, like dividing by zero. We need a theory that unites the very large with the very small. Perhaps not a point at all, but an exotic quantum state. Ideas range from tiny vibrating strings to a fuzzy quantum foam. For now, the singularity remains one of science's greatest mysteries. No information escapes. We push theory and search for clues. Not all black holes are created equal. They span stellar to supermassive with possible intermediates. Stellar mass holes are ghosts of mighty stars. Typically 3 to a few dozen solar masses scattered through galaxies, small but ferocious, powering some of the most violent phenomena. Supermassive black holes live at galaxy centers. Our Milky Way's Sagittarius A is about 4 million suns. Others reach billions of solar masses. They likely grew by consuming gas, dust, and unlucky stars. Horizon-size scales directly with mass. Elusive intermediate mass, and even primordial candidates may exist. The universe has many ways to forge these terrifying objects. Could you, even for a moment, survive the fall? It depends which kind. A typical stellar mass hole brings swift, violent demise. Tidal forces are astronomical even before the horizon. You would be stretched, squeezed, and torn apart. Supermassive horizons lie far from the singularity. Curvature is gentle. You could float across intact, alive and conscious inside. But it is only a reprieve. Gravity grows exponentially within. Mild at first, then terrifyingly rapid. Eventually, spaghettification begins deep inside. You might have minutes or hours before unraveling. Small, quick, brutal. Large, brief, conscious journey. A choice between swift death and a slightly more prolonged, profound one. The journey into a black hole remains a journey of the mind. We have described the event horizon, the warping of time, the terror of spaghettification, and the mysterious singularity. Scientists relentlessly probe these enigmas with ever more powerful tools, listening for faint whispers across the cosmos. How did early giants grow so fast? What happens to information that falls in? We have heard black holes merge and seen the shadow of M87. Each answer reveals deeper, more profound questions. They are the ultimate laboratories, matter, energy, space, and time pushed to extremes. By studying them, we learn star death, galaxy formation, even the universe's fate. They humble us and inspire generations to come. And so we continue to look into the darkness, forever asking, what lies within?